Okay, today we will discuss about resonant modes excited into DRA, and in specific higher order mode generation, their applications, the mechanism of generation, and then usage of these higher order modes for different applications. That is the topic of today's discussion. If we take an example of rectangular dielectric resonator antenna, for modes excitation, aspect ratio is responsible. Input feed and feed position is also responsible. When we talk about aspect ratio, A by B and B by D, these are the two different aspect ratios available in rectangular DRA. It means dimensions along x-axis, dimension along y-axis and dimension along z-axis will form aspect ratios, and generally we take 0.5 to 2 in between the value of these aspect ratio. If we plot a diagram of K naught D taking y-axis and B by D along x-axis, and we fix A is equal to B and keep permittivity of the dielectric material as fixed 10, then we will see when we plot these graph, the frequency, the resonant frequency of fundamental mode and higher order mode will come to that as we increase B by D aspect ratio, the frequency is getting decreased. Whereas if we take B by D aspect ratio as less, the frequency of the resonant mode will be higher. Now we will see that the mode generation and generation of higher modes and then control of these resonant modes even after generation of higher mode is being applied for different applications. I will narrate few. The aspect ratio governs the mode generation. The feed point also important parameter. The device structure, rectangular, cylindrical, and there can be various shapes, is responsible for mode generation. The coupling factor is also important for mode generation. The device dimensions is equally important. The value of substrate used in designing DRA is equally responsible. Then TE, TM, TEM and hybrid modes can be generated into DRA. Polymer, 3D printed flexible substrates are generally used to design this DRA. Then there is a beautiful technique of mode suppression. If we use even mode or odd mode or all even and odd modes, these configurations can be generated. So these comes in the category of mode control. When we keep ground plane intact, we are able to get the odd number of modes, and if we do not keep ground plane, we can skip this ground plane by certain methods, then the even number of modes can be generated. And there are few techniques where we can add even as well as odd modes. These are generally termed as hybrid modes. Then active DRAs, there are substrate which are being active substrate. It means if we supply some power, then these substrate value can be changed. Graphene is one example, and then BST, barium strontium titanate, is another example of active substrate. Then cavity and slots are equally responsible for generating the resonant modes, and they are resonant in nature. The stub we used for matching, and for feeding point there are various type of feeding techniques available, like aperture coupled DRA, then waveguide feed DRA, silver nano waveguide feed DRA, the microstrip feed DRA, coaxial cable feed DRA. So there are various feeding techniques. It means when I said that feeding point and feeding techniques both are equally responsible for generating fundamental mode as well as higher order modes. Then image effect is crucial in DRA design. If we keep ground plane, then the height of DRA will be doubled because of image effect. Then we have seen few cases that if you increase DRA height, your higher mode can be generated. Then nowadays new techniques are coming for designing MIMO using different DRAs. Then there are equations available to compute only resonant frequency. One is characteristic equation based and second is transcantatal equation based. Transcantatal equation this gives a better result because it is being developed based on dielectric waveguide model. So orthogonal Fourier basis functions are equally responsible to generate the modes over. Then if we are successfully generating higher order modes, but there is a certain limitation being extended. If we get higher order modes, uh, and if we compare these higher modes depending on the dimensions, if we increase number of modes in specific dimensions, then the overlap of modes will take place, and whenever there is a overlap, the radiation pattern will deteriorate. So we need to safeguard the higher order mode in certain limitations. We need to only increase higher mode up to that extent when the overlap of the mode does not take place. It means sufficient guard band is available to us. Generally, it should be lesser than 0.4 lambda. Then the azimuth angle, elevation angle, there are certain design rules are available, that how much should be the slot length in feeding, how much should be the stub length in the feeding. So these certain design parameters are there which restrict us to generate the fundamental mode and higher mode into DRA. I think this is basics of higher order mode, but we will try to apply these higher modes in mode splitting, in mode merging. So mode splitting, let us take what is mode splitting. We generate fundamental mode, then we generate first higher mode, then we generate second higher order mode, and these modes are separate apart. So we will say that uh, these are split modes. But if we by certain mechanism, if we club them, let us say the three modes are being excited, we want to club these three modes to a common juncture, then we will be able to get the bandwidth or extended bandwidth in this way. So generating higher mode and then shifting or merging these modes will give us the higher bandwidth applications. uh, Against higher bandwidth, we have one more application, that at higher order mode we have higher gain. Then playing with these resonant modes, higher order mode or fundamental modes, we can not only control gain as well as bandwidth, but we can see that focusing of beam is also playing a role. It means we can focus beam at certain points at certain distance. It means the beam width, the beam shape, the beam focus point is also in our control. So this way the designer get the manipulability as well as the control on the antenna parameters by using the concept of higher order modes. This is all today we want to discuss.